All right, we're doing a new chapter or a new unit. We're doing direct and inverse variation. Compared to Unit 6, with all those roots and zeros and all the things we were finding, and you had to graph and find A through G, and then that was Chapter 6. 7 and 8 got a little bit easier. I think 9, at least at the beginning, is even better. Okay, so I think you're going to be pleasantly surprised about this. Okay, what is variation? Let's even describe what this is at the very beginning. And variation, it's the rising or falling of something, someone said. But to vary is to change. It's the changing of something. There are 3 types of variation that are going to be on the slide, and 2 of them we're going to be talking about and having homework for. The first one is called direct variation. You will want to write direct variation. You're going to want to write y equals kx. I will explain what those words, these symbols are below after you get a chance to write it. All right, so direct variation says that y equals kx. These symbols down here are saying that as the value of x goes up, the value of y also goes up. That's what the arrow up means, okay? These examples of direct variation would be like you working and getting paid. The more you work, the more you get paid, okay? That's something that's direct variation. If one thing causes another thing to go up. You run an exercise, the faster you run, the more your heart rate goes up. The next one's called inverse variation. I'll talk about what's coming up on the screen in a moment. Inverse variation, I'm going to let you write inverse variation, and I'm going to let you write y equals k. That's over x. That could be a fraction. I would even write it more like this. Y equals k over x. That might be even... We'll talk about that one in a minute when you're done writing. All right. Notice the symbols down below say or show that x is going up, but what's happening to y? It's going down, okay? So examples of this, the more you exercise, the lower your blood pressure goes down, okay? So the more you exercise, that's going up, your blood pressure going down, or your weight going down even, okay? So that would be an inverse variation. And so I want you to realize that these don't necessarily mean good and bad. Direct's not good and indirect or inverse is bad. It's just the way things are. Sometimes it would be good the more you exercise that your blood pressure goes down if you had high blood pressure, right?
The more you eat, the more the weight goes up. Doesn't mean it's a good thing.
Right, and that would be a direct variation. The more you eat, more than your weight goes up, right? Now, this K. Let's talk about the K. I've got a little thing here on the side, and I've spelled something wrong on purpose. Yeah. It's on purposely spelled wrong. This right here is normally a C, right? It's normally a C. So K is the constant, and I don't know why they didn't put C in there, but C might be, I don't know. They just decided to use K. K is always used every time I see it for the variations. K is a constant, and that constant changes with the different scenarios. For example, we talked about the more you work, the more you get paid. Natalie might work, and she might get $10 an hour. And Isaac might work, and he might get $20 an hour. That constant is going to be different depending on who is working where and what position they have at the firm.
I'll take $20.
Okay? And so that constant is going to have to be found every time you do a problem because the scenario might change depending on the scenario. Yeah. That's going to be the truth for both direct and inverse. The last kind of variation, you can write it down if you want. You will not see this in your homework. It's just so you can be aware of it. It's called joint variation, okay? Joint variation is going to mean that we have more than one thing going on. This one says that X and Y are the only 2 things happening. But in joint variation, you're going to have maybe 3 or more things happening.
Will we be using this eventually?
Maybe in life, but not in Algebra 2. Okay, all right? So you're going to be doing direct and inverse right now, but I want you to be aware that there is more than just those 2. Okay, that you have heard those in the past. No, but more than that. All right, so what type is, you're going to tell me if this is direct or inverse. Right here. Y equals, XY equals 48. Is that direct or is that inverse? And how do you know?
It's direct.
I heard it's direct. So both of your examples had, what was solved for? Was solve for y. So let's solve this one for y. How do I move? What do I do to solve that for y?
Divide by X.
Divide by x, correct? So y will equal 48 over x. Is that indirect or direct?
Indirect.
Indirect.
That's
It's direct
inverse.
because it's not negative.
So let's go back to the previous slide that I had.
It's inverse. It's inverse.
And I said indirect, but I wrote in here inverse. Is we had y equals k over x. So if
Inverse.
x is in the denominator, it is inverse. If y is in the numerator, it is direct. Let's
Did you write it
do
down?
this one now. Let's do this one.
I never
Is
wrote
this
that down.
example, is this one direct or inverse?
It's direct.
I heard it's
Direct.
direct.
Because X is in the
X is on the same level as y, okay?
But it'll be in the numerator.
And the 2, if we were solving for it, would just come over as another constant. So this really would be y equals x over 2, or 1/2 x, and our constant would be the 1/2.
It's still direct.
It's still direct. You're right. It's still direct. So let's do this one. Is this direct?
It's inverse
I heard it's inverse.
because if you divide by 2 and then subtract by 3. Oh, no. It's direct because y is still in the numerator.
Are x and y, I always think of them on the same level. Are
X
they on the
and
same
Y is
level?
denominator.
They're on the same level. They're
it's
direct.
direct.
If x was below y,
You move the 2, not the.
yeah, the 2, you don't really have to move anything because it's solve for y. It's direct. All right, so numbers 1 and 2. Determine whether each equation represents direct or inverse variation. Number 1,
Inverse.
I heard inverse because
X is in the
denominator. Number 2,
Direct.
direct because x and y are on the same, they're multiplying. If you're multiplying, it's direct. If you're dividing, it's inverse. You with me so far? Okay.
I'm ahead of you, actually.
Good. Fantastic. All right, we're going to solve some equations. You will not understand what I'm talking about at first, but I would suggest you write these steps down. We're going to solve some variation problems. You might not have seen them in the past before, but the first step you're going to do is you're going to plug x and y in and find k.
The steps for what?
All right, after that, you plug in k and the other values and solve. There's 2 ands in there. You plug in k and the other values, if you want to change that and to a then, so it doesn't sound like there's so many ands in there. Go ahead. Plug in k and the other value and solve. All right, so here's number 11 and number 12. We're going to follow those steps. The instructions from number 11 say, if x varies directly as y, and x is 27 when y is 6, find x when y is 2. And that looks like what? Now let's find this first. First, let's just stop with the first comma. X varies directly as y, okay? So directly, is that where x and y are on the same plane, or is it one in the denominator? Same. So we're going to write it like this. Y equals, we're right here at the very first thing. X varies directly as y. We're stopping there. We said it's direct. That means it's this equation, y equals kx. Are you with me?
Yes, ma'am. It's true.
That's all it means. It's direct, so it's this. In a moment, we're going to do inverse, and we're going to have the other one.
So when you direct.
Oh, so all you're going to do is fill in the 27 into the x and the 6 into the y.
That's
and
correct.
solve for k.
That's correct. It says right here to plug in x and y and find k. So we have, it says x is 27 when y is 6. Those go together. So we're going to put a 27 in for x and a 6 in for y. So we're going to go 6 equals k times 27. You with me so far? Now solve for k. What are we going to do to solve for k?
Divide by 27.
Divide by 27. Reduce the fraction. K is going to be how much?
You can't reduce 27 over 6.
Yes, you
Oh,
can.
yeah, you can 3.
3, yes. So k is going to equal 2 over 9. Okay? So my new equation is y equals 2/9 x. Can I find x now?
Divide.
And instead of dividing, what can I do when it's a fraction?
Multiply.
Multiply the reciprocal. So I'm going to multiply by 9 over 2 and 9 over 2. My 2's are going to reduce, and x is going to be
Oh, yeah, 9.
9. Beautiful.
Hold that.
All right, so the first thing I do is I always find k, that constant. When I have that k, I plug it back in, so I have a general equation. And then I use the second half of my information to find the missing piece. We did a process like this when we were finding the equations of the line. And we had a point and a slope. And we were looking for the b value. We plugged everything back in a long time ago, chapter, 2 or something. Here, number 12. If y varies inversely as x and y is 23 when x is 8, find y when x is 4. So, what's my equation for y varies directly as x?
Y equals k over x.
All right, here we go. Now we have to find what first?
Okay.
K. How do I find K?
I was going to say, plug in the 23.
Plug in the 23 and the 8. Okay, so I'm going to put y is 23, K over 8.
And then
Multiply both sides by 8, correct?
Mm-hmm.
What is 23 times 8?
184.
184. I heard. Make sure that's true.
184.
Okay. So my equation is y equals 184 over x.
Over x? Over x.
Okay. The goal here is to find y when x is 4. So what do I do now?
Plug in a 4 for the x.
Plug in a 4 for x. So y equals 184 over 4. Y equals how much?
46.
I heard 46.
Yep.
Wait, you said 46. Okay. All right, let's review what we did on this lesson.
Really?
We're
Today we
done.
learned, yes,
Whoa.
you learned what inverse and direct variation was and how to solve equations with them. Goodbye.